Hello, welcome to Visionaryx, our podcast, where you can have real and simple conversations with us about various tools and technologies. I'm API Server and
I'm etcd.
I'm Scheduler.
I'm Kubelet.
I'm CRI.
in this podcast, we dive into exciting discussions about simple and deep technical topics in the world of DevOps and cloud. You can find the full transcript of this episode on our website, visionaryx.tech, to follow along with us. Stay tuned and enjoy the adventures in the world of technology. Hello everyone, I'm API Server, the brain of Kubernetes. I am like a big phone center where all cluster messages come through. My job is to check if requests are good, send them to the right place, and make sure everything follows the rules.
Hi, I am etcd, the cluster's memory and database. I keep all important cluster information. I make sure I always remember what the cluster looks like now and what it should look like.
Hello, friends. I am Scheduler. My job is to find the best node for new pods. I am like a house agent who finds the best home for new people.
Oh, what a nice group. I am Kubelet, each node's helper in the cluster. I make sure containers in my node are healthy and work as they should.
And I am CRI, Container Runtime Interface. I am the bridge between Kubelet and the container world. I turn Kubernetes words into commands that containers can understand.
Okay, friends, today we want to talk about one of the most important things in Kubernetes, pods. We want to show how we all work together to make a pod work well, from when it starts to how we look after it.
And it's important to explain how we use Linux primitives and why a pod doesn't have its own primitives, but uses Linux primitives only.
Yes, and how we use Container Runtime Interface, or CRI, as a standard way to manage containers.
Let's start and explain all the steps of making and managing a pod in detail.
Wait, before we talk about technical things, let's first say what topics we want to discuss.
I agree. For example, one important thing is what a pod is and why it is made this way. I always find it interesting why they called it a pod.
Yes, and why in Kubernetes we use pods instead of working with containers directly.
I think we should start with simple examples, like how a pod is like a pea pod with many peas inside, or like a house with many rooms.
Good. And then we can talk about what each of us does in a pod's life, from when it is born until
Until it needs to say goodbye. Oh, and we must talk about Linux primitives too. Many people don't understand this well.
And it's important to say how all these work together. It's like a music band where each person plays their own instrument, but together they make nice music.
So first, let's talk about how everything is built. Then we can talk about the small parts and what each of us does.
I agree. And we must talk about what we have learned. For example, I often have to make hard choices about where each pod should run.
Let's start from the beginning. Since pod is the main thing in Kubernetes, we should first understand why it was made.
It's interesting to know where the word pod came from. In nature, pod means a shell that holds things, like a pea pod that holds many peas inside. What a nice example. So Google was very smart to pick this name. Just like a pea pod, our pod can hold many containers together.
And what's more interesting is that these containers in a pod, like peas in a pod, share one space. They are born together, live together, and end together.
Exactly, and this is one of the main reasons we made pods. Sometimes we need some containers to always be together and share things.
Let me give a real example. Think you have an app that makes logs and another container reads these logs. These two need to always be together, just like two peas in a pod.
And it's interesting that anything that wants to be in a pod must work with Container Runtime Interface. This means it must be able to become a container and use Linux primitives.
But this is not a bad thing. It's good. It makes everything follow the same rules, so we can manage all workloads the same way. I agree. And it's interesting that we're not limited to one type of workload. Anything that can become a container can go in a pod if it works with how pods are made.
Let's start with a simple example. When I get a request to make a pod, I get it first. It's like a building plan that shows which Linux primitives to use.
And I save this plan very carefully, because we always need to know what the pod should look like and which primitives it should use. I need to say something important here. A pod doesn't have its own primitives, Many people think wrong and think a pod is a new primitive. But really, a pod is just a way to use Linux primitives.
Right. Let me give an example. When we say a pod uses Linux primitives, what do we mean? It uses namespaces to keep things separate and C groups to control resources. These are the main Linux primitives.
And it's interesting that all these talks happen through system calls. When we want to use these primitives, they become Linux system calls in the end.
Now that we know the basic ideas, let's look at how things work. When I need to decide where to run a pod, I must think about many things.
What things do you think about?
Well, first I check resource requests and limits. Then I look at node affinity and pod affinity, and that's just part of it.
Yes, and when the pod comes to me, I must make all these things happen. For example, when you say this pod needs 2 gigabytes of RAM, I must use C group to make this limit work.
And this is where I come in. I must turn these requests into container runtime language. For example, when we say a pod needs network isolation, I must turn this into the right commands to make a network namespace.
And all these must be POSIX compliant and run at kernel level. This focus on security and good performance is what makes Kubernetes so strong.
I save all these settings and changes, because if something goes wrong, we need to know what settings each pod had and how to get it back to that state.
By the way, it's interesting to see how pods have grown over time. Remember when we could only put a few simple containers together?
Yes, and now look at all the new things we have, from init containers to ephemeral containers, from pod security policies to pod disruption budgets.
And it's interesting that all these new things still use the same Linux primitives, like for pod security policies. We just use the same Linux namespaces and capabilities.
Well, now that we're talking about changes, let me tell you something interesting. Before I was born, each runtime worked with Kubernetes in its own way. It was like they all spoke different languages.
Yes, and what a hard job it was for me, having to talk to each one in a different way.
Dear CRI, you're like a world translator who made all runtimes speak one language, just like that universal power adapter we use when we travel. And I remember how much my data structure had to change to support all these new things. From adding volume sharing between containers to pod affinity, anti-affinity.
Remember when pod priorities came? My job got much harder then. Now I had to think about priorities along with resources and limits.
Friends, let's talk about Pod Sandbox. Many people don't know that when we make a pod, we first make a special safe space called Pod Sandbox.
Yes, and this is one of the most important things I work with. Pod Sandbox is a safe, separate space where all containers of a pod live.
Can you tell us more? I think many people don't know about this.
Look, Pod Sandbox is like a safe bubble around all pod containers. This bubble has all shared namespaces like network namespace and basic things like DNS settings and security context.
And it's interesting that we make this bubble before any containers. I first ask CRI to make a pod sandbox, then we put containers in it. And I must save and keep the state of this pod sandbox too, because it's part of the pod's full state.
What's nice is that this setup makes it easier to manage shared things between containers. Like when we talk about network policy, we put it on the pod sandbox, not on each container one by one.
And another technical thing, we also have container sandbox made for each container. So first we make pod sandbox, then make a container sandbox for each container. This layering helps us share things safely and keep things separate properly.
Exactly. This layer design is very smart. Each layer has its own job, and together they make a safe and good system. Yes, you're right. Security context in pods is very important. With good settings, we can control what containers can do and make our cluster safer.
And it's my job to make sure each pod starts with its own security context. When someone makes a pod, I look at all its small parts.
I save all these settings so we can look at them later or get the pod back if we need to.
Friends, let's talk about how to look after a pod's life, from when someone asks for a new pod until it goes away.
Good idea. When I get a new pod, I first check if we can give it all it needs.
And I help Kubelet at this time to make pods containers using the right runtime.
Right. First, we make a pod sandbox to give the pod a safe space. Then we run the containers in it.
I watch the pod all the time and tell clients what's new.
And I save how the pod is now and how it should be. This info helps us all work together well.
If a node can't run the pod, it's my job to move it to another node.
And then I must tell how my node is doing so Scheduler can make good choices.
Also, if a container in a pod has a problem, I tell Kubelet so it can help.
We might need to restart the container, or if it's a big problem, make the whole pod again.
And when these things happen, I tell clients so they always know what's going on.
Let's talk about volumes in pods. Pods can use volumes to save their data. Yes, when a pod needs a volume, it's my job to connect the right volume to it.
This is where CSI, Container Storage Interface, comes in. It lets us use many types of storage.
I must also make sure the node I pick can work with the volume that the pod needs.
All these small parts are in the pod's plan, and I send them to everyone who needs them.
And I save all the information about volumes and how they connect to pods. Also, we must not forget about init containers. They run before the main containers and help get things ready.
Right. Init containers can do things like load first settings or check if everything is ready.
And I must make sure we have enough things for init containers too.
Also, we can use readiness and liveness probes to check if pod containers are healthy.
And I tell clients about this so they know if pods are ready to work or not.
In the end, all this working together helps pods run well and makes apps work nicely.
Yes. And this shows how important it is for all of us to work together to make a pod work well.
That's why pods are the heart of Kubernetes, and we must always try our best to look after them.
I agree. The better we work, the better the cluster runs, and the more we can trust the apps.
Well, friends, I think now everyone knows what each of us does in a pod's life. Yes, that's right.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website, visionaryx.tech.
Goodbye for now.
Goodbye.
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 Goodbye.